Lesson 1 of Module 5. We are 2/3 of the way there. We're going to graph linear inequalities in two variables. So instead of graphing lines, which are just straight equals, we're going to look at greater than, less than, greater than or equal to, less than or equal to. So the first thing we need to do is figure out whether points are solutions to inequalities. And all you got to do is plug in the values. So for this one, I'm going to do 5 times the x value, which happens to be 5, minus the y value, which is 15, is greater than 10. And then I just have to see whether that works again. I plugged in 5 for x, 15 for y, because that's what the point tells me to do. So it's going to be 25, take away 15, greater than 10. Is 10 greater than 10? No, it isn't. This is false. So the ordered pair (5, 15) is not a solution. So let's do B. Similarly, I'm going to put -1 in for x and 2 for y and determine whether it's true or false. -2 plus 6 is less than 10. 4 is less than 10. Yes, the ordered pair (-1, 2) is a solution to the inequality. Spelled inequality wrong. There we go. Okay, last but not least, we're kind of beating a dead horse here. -2 times -2 plus 3 less than or equal to 4. 4 plus 3 less than or equal to 4 is false again. So -2, 3 is not a solution. Okay. Now we're going to take a look at graphing them. It's wonderful and everything to plug in points and try to get where things are going, but I want to get a nice picture of the entire solution on a graph. So here we go. It really only has 2 steps, so let's rock and roll. So the first step is I need to graph the boundary, which is x is equal to -2. And I have to decide whether the line that I'm going to be graphing is included in the solution or not. In other words, the boundary has to either be dashed or solid. It's solid if I want to include it. Solid is greater than or equal to or less than or equal to. I do a solid line. And then greater than or less than, I do a dashed, because I really want the solution to get close to the line but indicate that the line is not part of the solution. So here we go. X is equal to -2. It's one of this cute lines where x is always -2. Y can be anything I want. I label my axes. -2, 0, 1, okay? And since the original inequality is greater than or equal to, I'm in the solid line category. Because when x is equal to -2, it is part of the solution. -2 is greater than or equal to -2. Now I'm going to shade, get it? Shade. Okay, I'm going to shade one side or the other of the line. And so what I'm going to do is I'm going to pick a point that's not on the line. And the easiest point to pick if it's not on the line is the origin. So I'm going to pick 0, 0 and use the original inequality And I really only need to plug in for the x value. Is 0 greater than or equal to negative 2? Yes, it is. 0, 0 is right here. Since it's true, I'm going to shade toward the point 0, 0. If it was false, I'd shade the other side, and I'm done. Let's go on. We'll do a couple more examples, just very. Okay, so first we need to graph the line y is equal to 5x take away 3. This line is in slope-intercept form. Yay! We have to decide whether it's solid or dashed. I look at it, it's greater than or equal to, that means it's solid. So I'm going to start at negative 3, label my axes, of course. Start at negative 3. The slope says to go up 5, 1, 2, 3, 4, 5, and right 1. There it is. And since it's solid, I'm just soliding the line. There it is. Now I have to shade. So I'll draw my little sunglasses. And now I'm going to shade. So 0, 0 is not on the line, so I am going to pick the origin as my point and put it into the original inequality. Not the line, because it doesn't help me. So 0 for y, 0 for x. Is 0 greater than or equal to, 5 times 0 is 0, take away 3 is negative 3. Is 0 greater than or equal to negative 3? You betcha. So here's 0, 0 on the graph. I'm going to shade toward that point because it's true. True. And I'm done. Okay, let's look at the next one. First, we're going to graph y equals 3x. Now, since this is greater than, the line will be dashed. Okay, label my axes. Beautiful. So the y-intercept is 0, 3x plus, there's 0 there, so I'm going to start at 0, 0. Slope says to go up 3, right 1, and then don't forget to dash it. I love graphing these in my math lab. It's so much more refined. Okay, so now we have to pick a point not on the line, and unfortunately this line is going through 0, 0. So I'm going to pick, I don't know, let's pick a point 5, 0, which is way out here, 1, 2, 3, 4, 5. So I know it's definitely not on the line. And I use the original inequality, put 0 in for y. Is 0 greater than 15? No, it is not. It's false. So I know this point is not in the solution. I'm going to shade the other side. Okay, next slide. Okay, last but not least, let's take a look at this guy. And this is just a line in a different form, so I wanted just to do an example of this. So we're going to look at 3x plus 4y is equal to 12. That's my boundary. And since it's greater than, without an equal to, it's going to be dashed. Good? Now for this one, yes, I can put it in slope-intercept form if I want to. Or I'm going to take this opportunity to review some intercepts. So what I'm going to do is I'm going to do the tic-tac-toe method on this. When x is 0, 4y is equal to 12, y is 3. So 0, 3 is on the line. And when y is 0, (3x) is equal to 12, x equals 4. So 4, 0 is on the boundary, and I want to dash it. because I don't want to include the boundary. Now, the beauty of this is now I can pick 0, 0 again because it's not on the line and put it into where? Let's hear it. The original inequality. You've got it. So I'm going to put 0 in for x, 0 in for y. Is 0 greater than 12? No, it is not. 0, 0 is right here, so it's ain't. So I'm going to shade up in the opposite way. Now you're going to be able to do the next written assignment in the book and the assignment in My Math Lab. Keep going. You can do it. All it takes is a little bit of effort. Go for it.